So, dear participants, a very good morning. Today is the chief guest is set to join. He'll be joining in another 1 or 2 minutes because he is having some internet issues. So he'll be joining in another 1 or 2 minutes. Please make use of this session. You are going to interact with a professor from the NIT, and we need your cooperation for successful completion of this event. And the certificates will be issued within 1 week for those who have attended all the 6 days of the event. Please wait for 1 or 2 minutes so that the chief guest will join. We will start the meeting. Sudha madam.
Yes, sir.
Just now, chief guest called me. He's having some internet issues there.
Okay, sir.
He'll be joining in 2
sir.
minutes, ma'am. Yeah, thanks.
Okay, sir. Sure, sir. Sir, good afternoon, sir. Sorry, good morning, sir.
Good morning, sir.
Good morning, madam. Is it audible?
Yeah, audible.
Yes, sir.
Right. Thank you.
I will stop my screen sharing, sir. Probably you can check whether you are able to share your PPT. Then we will start the session, sir.
Okay. Shall we start?
Yes, sir. Just before that we will check the PPT whether it is shared properly from your side. Can we do that, sir? Yes, sir. It is visible, sir.
Yeah.
Yes, sir. It's visible, sir. We'll start, sir.
Yes, yes.
Yeah. Dhanlakshmi, ma'am. Sudha, ma'am.
Yes, sir, ma'am, will start.
Yeah. Good morning to all. I welcome you all for the Day 6 FDP on Next Generation Computing, Key Trends, Challenges and Opportunities, which is organized by the Department of Computer Science and Applications. Now, I request Mr. N. Krishnamurthy, sir, Assistant Professor, MCA, to welcome the gathering.
Good morning, ma'am. Good morning. Am I audible?
Yes, sir, you are
Ah.
audible.
So, very good morning to one and all present here. I feel proud and privileged bestowed on my shoulders to propose the welcome address for the 1 week international FDP, the last day of the event. On behalf of the management, on behalf of the department, on behalf of all the faculty members, I extend a cordial welcome for today's guest speaker, the renowned member, the well-known member in the area of academics, Dr. S.R. Balasundaram, Professor, Department of Computer Applications, NIT, Tiruchirappalli. Sir, welcome, sir. And,
Thank you, sir. Thank you.
Thank you. Your presence adds color to the FDP because undoubtedly the title what you have given, you are the right person to handle the session for the title. And the data science is playing an important role in current scenario. All the industries are moving towards data science, and the FDP what we have designed will be useful for all the participants, research scholars and students to elevate their research interest. Once again, I welcome our beloved professor, the well-wisher of our institution, as well as my well-wisher for the FDP. Thank you, sir, for sparing your time and accepting your invitation. So within a short period of time, the professor has accepted our invitation, and thank you, sir. And I welcome all the participants, professor, heads of departments from various institutes, faculty members from various institutions, research scholars from various institutions, and students, as well as my own colleagues. Once again, I extend a cordial welcome for the chief guest of today's function, Dr. S.R.V. sir. Thank you, sir. Thank you for accepting.
Thank you. Thank you.
It's my pleasure, and your presence as well as your blessings is essential for all the participants. We will also like to reach your position in the place of research and academics. Your blessings as well as your session will definitely guide us to our milestones. Thank you. So with this, I hand over the session to Dhanlakshmi ma'am. So to you. Welcome, most welcome, sir.
Yes, sir. Thank you, sir. Now I call upon Mrs. V. Pavitra ma'am, Assistant Professor, MCA, to introduce our chief guest.
Yes, ma'am, you are not audible.
Good morning to one and all present here. I take this opportunity to welcome today's chief guest, Dr. S.R. Balasundaram, sir. He is working as a professor in the Department of Computer Application, NIT, Tiruchirappalli. Sir has nearly 25 plus years of experience in teaching field, and also he published more than 60 papers in reputed journals and proceedings of international conferences. Sir holds a master degree in MCA from PSG College in Coimbatore, and also he completed ME in Computer Science and Engineering. Sir earned his doctorate degree in e-learning and assessment from NIT Tiruchi. He has played various roles and responsibility in his career so far: head of the department, program coordinator, and guided several number of PhD scholars. He handled various subjects: object-oriented programming, analysis and design, software engineering, internet and Java programming, web technology for PG level students. And also, sir is associated with computerization, a national level admission process, and also a member Center for Entrepreneurship Development and Incubation under the aegis of Ministry of Communication and Information Technology, Government of India. It's my pleasure and privilege to introduce him for this session. Once again, a warm welcome for this session, sir. Now I request our chief guest to take over the session.
Thank you.
Sir, thank you, sir. Can I add
Thank
one
you,
more
sir.
thing, sir, before you start?
Yeah, 1 second.
Yeah. Which I remember that in the year 2005, NIT was conducting an event in research directions. That was actually coordinated by Dr. SR Bisari, our chief guest. So that day, I got, he impressed me a lot. That means how to conduct a function, how to get funds from MHRD like that. I had an interaction with him for nearly half an hour. Even after 16 years of that incident, I could not forget the way he blessed me as well as guided me for my research and as well as my career. Thank you, sir. I still remember the day when I met you in NIT.
Yes, yes, certainly,
Thank you.
certainly.
Thank you, sir. Please, please
you,
carry on,
thank
sir. Thank you, sir.
So thanks for recollecting a wonderful experience. And so let me start.
Definitely, sir. You can, sir.
Yes, sir, with pleasure, sir, you can start.
Yes, yes. So it's with great pleasure that today I'm here to spare some time with all people from academic and other parts of the system. So first of all, I thank the management, the department, and the organizers, Krishnamurthy, and the department members for giving this opportunity to highlight few points on this current topic. Rather, I cannot say it as a current topic. It is already there for a few years. It's booming like anything. So as per today's topic, we are going to see what is data science and what are the next level features added to them, added to data science applications or projects. And finally, what else needed? This is the broader three segments we are going to see. Hope the slide is visible.
Yes, sir. It is visible, sir. It's visible, sir. Visible.
See, what is this data science? As all of you know, we can simply say that it is a new buzzword. Rather, a conceptual view given for an already existing set of techniques, concepts, procedures, etc. Well covered under the heading data science. But when we talk about this data science, what happens is, say, for example, we are searching in the net. A lot of related terminologies will emerge in whatever search engine you try. Say, if you try through Google, if you search data science, AI will come. If you search for AI, cloud will come. If you search for cloud, big data will come. So at some point of time, we are given a lot of terminologies, but always having a kind of fuzziness, where these three things or four things or n things are differentiated. Rather, the truth is, the fact is, we cannot differentiate them. One has emerged from other as a separate discipline, continues to evolve to give birth to a new direction. In that case, data science has come as an umbrella for the earlier existing kinds of things only. Now let us see these things. Like If you see from net, one simple or easy way to understand about this field is that the left Venn diagram, data science sits in the most intersecting part of other domains such as maths, statistics, domain knowledge, computer science, and also software development, then slowly machine learning, then business analytics. So this is a very simple and easily understandable, but still to be explored process. How software development is related to data science, how machine learning is related to data science. If you explore this, again, you will get a lot of intersections, Venn diagrams, etc. In another perspective, you see the next Venn diagram. Based on the roles or responsibilities, these things have been explained in a different way. If you take domain knowledge, client requirements, what are the important criteria to be taken care? Similarly, if you take mathematics, what kind of mathematics? Whether all types of mathematics needed? Or what are the prominent mathematics or statistical components required for nearing data science? Similarly, in computer science, do I need to include a subject like DBMS, operating system? In my curriculum, I had in computer science something called, what is that? Automata theory. Will it come there? So many things are yet to be analyzed, but there are some prominent subjects that are closer to data science. Similarly, each of the circles you can explore further to get further insights. Now, this another diagram which specifically tells, okay, we have come to a stage of data science, but be specific on these terminologies like pattern recognition, data mining, knowledge discovery, AI, visualization. There's another perspective to go inside data science. So like this, if we go, still two more diagrams are there. This just to these 4 to 5 diagrams to give an impact. Still, we don't have one line definition for data science, but even if it is one line, it is going to be an abstract definition only. Let us see this. This is somewhat better. A company person will like this. Like we have big data, we have AI, machine learning, each one of them having its own role. Say, for example, if it is data analytics, curating meaningful insights from the data. If it is AI, making machines to perform thoughtful functions, cognitive functions. Similarly, for each of these things, we have some responsibilities, and through that, we try to understand the principles of data science, as it is the science of deriving predictions from the insights to benefit dash. Though it is given as business, it can be for any application context, any context. It may not be business alone. This is a different perspective. We have 3 segments here. The first segment tells about all related to the significant areas of AI. Then AI alone, machine learning, deep learning, with respect to examples also. Say, for example, Amazon purchase prediction can be coming up to artificial intelligence. Machine learning for Facebook facial recognition. Deep learning for self-driving cars. And from this, we emerge one area or one focus having subdivisions, starting with data mining, analytics, analysis, then science. See, if we explore this diagram itself, a lot of things can be understood. But one point here I would like to stress. Let us take an example of facial recognition. From this diagram, it is given as machine learning is used for facial recognition. Does it mean that till machine learning came, or it is understood, or it is applied, was it not happening? It was there. Before the application of machine learning in facial recognition, or before the application of AI, that term AI, in the context of email classification, process was there. Many people were doing, but with the raw techniques or terminologies being used. If you go back, even you can see 80s, 90s papers, research papers, a lot of good papers are available. How classification and clustering were considered to be the topmost research in mathematics. When mathematics research was purely on real analysis, complex analysis, all those things, when it went for applied domain, this classification clustering started introduced in the context of mathematics research, rather mathematical applications. But now it is getting refined, same classification clustering title only, but it is being referred by big data domain, AI domain, data science. In future also somebody will use this same technique. So from this slide, 2 points we have to note. One, there are a lot of underlying techniques that continue to evolve. They have longevity, like clustering, classification, graph theory, optimization techniques. They are all immortal. They will continue, but only the titles will change. Domains where they get applied may get different terms. Even the concept of AI, as you know that it has got transformed from a simple level to recent level. In between, there was a term called cybernetics. The term cybernetics was coming up during 80s, mid-80s, but due to some reasons, it could not get popularity. Even then, cybernetics is one of the important terminologies in computer science field. So this diagram ends up like understanding that statistical techniques or mathematical techniques, what we had, like regression or correlation or something like classification, all these things taken by data mining umbrella. Then we have data analytics umbrella. Now we have data science umbrella. But in between, there is one important segment as researchers, we should focus data analysis. This data analysis is important. It is a process of inspecting, cleaning, transforming, and modeling data. Rather, data analysis helps you to interpret what happened, what is being obtained as output, is it correct or wrong? So data analysis is very important. Now, as you see, assuming that data science is related to, so till the previous slide, our focus was on bringing the neighbors like big data, data analytics. and to console ourselves that just data science alone cannot be defined. For making it understandable, other domains also have to be linked. That is the purpose of the earlier 4 slides. Now coming to a conclusion that, okay, hereafter we are going to focus on data science. As you know that there are a lot of applications of data science, maybe in commerce, e-commerce, or finance, or business, or healthcare, or entertainment. In all these things, data science has been spread. But if you see inside, whether it is finance, or whether it is business or healthcare, except a few technologies, most of them are already being covered. Whether it is Sensex, or whether it is a kind of game like football, or whether it is a kind of population related statistics, election related things, all these things have been done. They have been modeled, experimented, etc. But with the coverage or the statement statistics alone. But now we are giving new terms like analytics, real-time analytics, sentiment analysis, all those things. So it's a broader spectrum of applications where data science is enjoying its, rather the other way, all applications are enjoying the benefits of data science. To make it simple, applying scientific skills over data to make use of data. We have data. We have to apply science. See, now we have to look at this point very carefully. What is data and what is science? Science is more related to principles, procedures. Then only comes fixing that as a standard through engineering. Without science, engineering cannot come, or technology cannot emerge. So the people started thinking that it is better to apply scientific principles or regulations for data. And when we come to data, I think by this time all of us know that there are plenty of data coming from various sources. Sources are different, formats are different, expectations are different. The segments where this data to be processed are different. If you talk about data itself, it's a very big journey. You cannot confine data with 1 or 2 definitions, though we call it as a raw value. You see, people are exploring the things on hidden data. When current research is going on fake data, hidden data is a very prominent research. It is almost like deciphering. Say, for example, something is there in an image. Can I get something more from that image? How to get more details about the hidden data? It can be from a photograph, or it can be from a noise, etc. So applying scientific principles to data, we have the concept of data science. And here we have many segments, predominantly data visualization, manipulation, statistical analysis, and machine learning. So visualization is a very interesting part of any segment. As an image can speak a lot, visualization can always help you. One important thing I would like to mention here, as most of you may be aware, in writing a paper or publishing something, we bother about getting the final visualization part. From a table, we will draw a bar chart or some kind of graph chart, and we say that our paper is over. Our research paper, I have experimented in this platform. I have taken this much of data, and rather 2 or 3 data sets have been taken, applied the concepts or procedures, and how each data set is being projected is shown in the graph. Hence conclusion, paper submitted, degree also obtained. But try to have this in mind. Your research or your analysis should start only from visualization. Visualization is not the end of a process, it is the beginning of a process. Say, for example, if you take research on social network analysis, somebody has applied some algorithm, and you have to first run that or experiment that using the available tool and see what happened. Maybe this may be available as a kind of graph given by other person also, but it is better to experiment by us and see that result. And here comes the major point. Am I able to find any discrepancy or issue in that figure? Or whether this data, by changing the data, what kind of new graphs or charts are coming? Why such things come? So our literature survey also should come from visualization. Most of our literature survey is like a tabular form, like some author, year, journal, volume, all those things. But one of the topmost point to be considered in literature is whether this chart is getting, what is that, redesigned or moved, reoriented for other data. We change the data, whether the results are coming as per the algorithm. If not coming, we are the luckiest persons. A problem has been obtained. We can start our research. So coming back, data visualization is very important. That is driven through design. That is driven through design, where we can do a lot of plots. Plenty of plots are available. Tools are also available. And now again, interpreting that graph or chart is very important for a data scientist. There are some rules and regulations which chart to be used for which type of context. Data manipulation. Already we have talked about the data which is of semi-structured, unstructured, quasi-structured, etc. etc. Different formats are available. It can be audio. In fact, I would like to stress here one more thing. Yeah, according to one of my friends at Canada, he used to tell the term multimedia is wrong. Multi means though we can understand more than one, but he is telling that the multimedia is what we call it as audio, video, text, graphics, and animation. If we closely look into it, they come under only 2 categories. One is visible, another one is audio related. Either it can be sound or voice, or the voice present in the video. It is only bimedia. For quite some time, we have been using multimedia just like that. So what are the other media? Nowadays, we are having sensory. Sensory media as another input. Thought process as the fourth input. Now only the real picture of multimedia or definition in 2000s only we are getting. Though we have 5 different types coined under multimedia, according to him, he is telling that it should not be called as multimedia, it should be bimedia. Coming back, your data can come from various places, formats, sources, media, but whether all of them can be used? No. So in that case, they may be untidy. We cannot draw inferences. So we have to refine the data, structure the data, and based on that, we have to find the insights. And need not be always a kind of square matrix or a kind of M by N matrix of this type. That data cleaning itself is a very tactical process which needs domain knowledge to be understood. Statistical analysis, an immortal one, to understand data through max statistics, the nature of data, explore the relationship between data. That's important. So a lot of techniques are used like regression, sampling, shrinkage, dimension reduction. So already these are all open to us, but we were waiting for these big data, data analytics, data science concepts to be, what is that? Use them. But all these things are there, as all of you know. And the concept of machine learning, again, it is not new, as all of you know that. These are all already existing. It is actually one of the oldest authors say, I have been writing this for quite a long time. My book was not sold. I was surprised. The same content has been, I saw in the market, same book. Whatever I wrote, he also has repeated the same thing, but with a different title. Maybe the title has given a kind of, why I'm telling this, machine learning is not new, as all of you know. These things are already existing, have been applied in, what is that, macro level domain, say whether it is airlines or oceanography or a kind of seismic analysis, geographical information systems. Quite some decades, these kind of things are well used. Maybe not under the heading machine learning. That's all. This is the second part of that, understanding what is data science, what are the major components. Now let us go to an interesting article. I liked this article very much, that's why I'm giving here. What is the life cycle of your data science concept? Acquire the data, clean the data, use or reuse data, publish it, preserve or destroy, reorient. And in each of these steps, you have got plenty of sub-steps. How we are going to acquire? Earlier, it was lab or surveys, devices, simulations. But that more has got more meaning. Data acquisition itself is a very, so what are the techniques already followed? In fact, you can have this as a basis for exploring the current trends. Not only what I am going to highlight, few things only I am going to highlight, but we can always make this slide. Have we exhausted all the possibilities for data acquisition? What is that more? Now we have sensor based, RFID based, other device based. It can be mission to mission or human to computer, or it can be device to device, moving towards signal to signal. It has got a lot of this data acquisition part itself is a very big ocean. Without talking, I am telling to somebody by my just data is acquired. The captain is telling to the teammate, do this, who is at a long distance in the ground. Data is acquired. Then it is acquired in the proper sense, interpreted properly, they're all different. Similarly, cleaning, we have organizing, filtering, annotating, etc. Using or reusing, we have got so many things, mining, visualizing, designing, etc. Publishing, we can do plenty of ways of publishing, like aggregating, collecting. Say, for example, in publishing itself, let us think of Reuters. Reuters is a news website which has been using a lot of techniques or technologies, like CNN, Reuters.com. Almost it is trying to involve all types of information retrieval. I would like to stress this also. Information retrieval is a higher level term for most of the terms what we use nowadays. So the CNN as well as Reuters, they have got plenty of techniques. One technique is aggregation. There are some wonderful softwares or tools available with them, collecting data from different news agents of their domain, making it as a kind of summary, and then giving it for publication. So this is aggregation itself is a very important technique that involves NLP as well as text processing. Then whether we have to preserve, that is keep it or destroy, that depends on our domain or usage, how we are going to preserve, where are we going to ignore it, whether it is a temporary data to be ignored or it is a data to be revisited. And based on this figure, this is the research. See, why I specifically brought these two slides is, this is a reference given by Berman in communication, ACM communication. Based on this, another group of people are elaborating it. That is actually a research contribution. They have defined this into application level, infrastructure level, system level, where every level, how better things can be or new things can be done based on the trends. The trends in AI, the trends in cloud, the trends in other inner domains also. If at all a new database like something like columnar database has come, or a new database like lot of data graph model has come, whether that can be applied here. Similarly, in networking, any new feature has come, whether that can be applied here. So this is a wonderful architecture they have given for that cycle which was given earlier. This is only an abstraction. And you see the next line is very important. This is not only a research, it is also a patent by that person. He is telling that though we have given a lot of blocks in each of these layers, depending on your organization or requirement, you can customize. See, this is the best definition of any work. From something else, we are trying to generalize it and then giving to the society. And from that, how they can customize that. So that's why I have purposely given this slide, which I like very much. This is a wonderful life cycle. Now let us come to the major part of that. There are a lot of trends, as I already told. All these trends are interwoven. Sister concerns. If that is there in big data, that also can be used here. This is available, there also I can use. But after all these things, I am interested in focusing only few of them. So in that line, user-generated content. Focus on user-generated content. See, if you take care of e-commerce applications, other than the company or the organization showcasing or displaying the product's details, all other details, can I get data from the users? There are various stakeholders, and whether the data can be useful for me. And if so, how well that can be used. Say, for example, if it is about a restaurant, somebody would have given some kind of opinions. From that opinion, is it possible to generate, say, for example, if it is given in a restaurant opinion suggestion, the tables are not clean. Somebody would have gone there and he might have seen the facilities given in the restaurant not proper. Now, based on this, understanding the semantics of that, and next time, photographs which will show better things of that complaints. If there is a complaint, to remove that complaint, some better photographs. So this itself is a very big, not a project, but a big research. So based on the visitors, the engaged users, value of the content, so many other metrics like this, all metrics, virality, notification, how the improvement for the business can be thought of, how the rectifications can be thought of, etc. So this we call it as user-generated content. So now data science people needed for this user-generated content analysis is required. From that content, applying NLP. Next slide will give some more related to this, something related. Apart from NLP, how I can project the videos as per the requirement. So this is a very big domain. Data generated content instead of just user generated, let us go for data generated content creation. So the next wave for data science applications is towards how we can write product descriptions or creating highlights videos for sports events. This is a text-based or video-based projection, similar to the earlier one. Suppose somebody has given for what is that? A furniture shop. Only the front view of the furniture has been shown in the website. I am not able to get the complete. Only the what is that? Few photographs of that vehicle is being shown. I am unable to see how it will go with respect to different temperature conditions or climatic conditions or road conditions. I don't have. So in that case, online is waste. a comment may be there. So to nullify that, with the help of deep learning, again neural network, again graph theory, again max. We have a lot of models that have emerged. How well realistic images can be shown to get a clarity over the product? It should give an impression that almost the product is shown to the user. There is only a one image, but how you can get different views of that image? A lot of this is all already done. Like given a side pose of a person, is it possible to generate the other angles also, transformations also? Our good old graphics transformations are coming here, which are being taken care by GAN models, stack GAN, all those things. And transformations, predictions. See, this bike is going in something is captured in the CCTV. This bike is going in a very, what is that? Abnormal speed. What will happen next? Is it possible to inform? Of course, that comes under IoT. But anyhow, that prediction with respect to the existing videos, video clips, photos, these things are data generated content creation that plays a vital role in many places, more specifically in real-time analytics. One of the recent papers is that a CCTV embedded placed in common user, rather public area in a marketplace, a busy place, a kind of intelligence is being applied to that camera by seeing the crowd, whether it can inform to the police or the security that a mob is going to take place. By seeing the abnormal behavior of some few people going here and there, their patterns, their physical patterns, behavioral patterns. So it's a very great work. It is not only with respect to video. It also combines with human behaviors. See, now we are in the stage of object tracking, object motion tracking, all those things. If I can simulate all activities of a dancing, whether it is Bharatanatyam or Pole, any kind of dance movements can be trained, and I can show some other image doing these kind of things. As an expert in particular art, I can train the model, and that model can be shown through some other image, which is well done in entertainment industries. That's there. But is it possible to understand the abnormal behavior plus IoT? Accordingly, can I give a caution to the security? So this next layer, which will be very much required in current system. Now we are moving to a very drastic question. Who is a researcher? A researcher is a person who cannot get satisfied. There are only two people who have driven the system. One, a lazy person. The other one, a questioning person. A lazy person, say for example, if somebody is asking me to go to market and purchase, if I am very busy, I will feel, is there any possibility somebody will bring whatever I require? Certainly somebody would have thought over this some decades back. Now it has come up to Swiggy or Zomato or such kind of home services. E-services have come, but analyzed by an external person. Similarly, a questioning person. Questioning persons will always help indirectly the system. You see, this is a question whether big data is needed for everyone. And the same Gartner, who is noted for doing a lot of statistical surveys, who is famous for Gartner report, he has given a drastic question. 70% of the organizations will move towards small data. See, currently in our research also, though we are claiming big data and all, we are using only some megabytes or something like that. Very rarely terabytes or petabytes are being used. But there is a problem there. Whenever something is tried over a larger domain, whether the result is, I am linking this to the next one also, trustworthy, whether it can be holding good for the entire domain is a question. So people are moving towards small data. For this context, small data is enough. Say, for example, COVID-19, there is no past record. Most of the research papers that you can see, 2021 papers, literature is about earlier SARS or whatever it may be. The historical data could not be used in COVID. COVID research is not depending on historical data. Only that domain data, that region data, that person's data. So in that case, big data is getting shrunk depending on the context. Though it is less data, it can offer much insight. Especially last one, few short learning, synthetic data or self-supervised learning. Small data is very important. A good comparison we can always see. Small data batch to real time need not be fast, easier in terms of veracity. For private data, we can go for small data. Most of the testing aspects can be done with respect to small data. To understand in a different way, correlation always used in data, but why of that causation is focused in small data. When we talk about this why, it automatically relates to the next topic. When the technology has given rise to help the movers, people who are traveling through various facilities like Uber, Ola, all those things. See, the technology has stopped up to some, or we wanted to use that for linking the vehicles to the persons, either static mode or static mobile mode, mobile static mode or mobile mode. But to improve the business, one more layer of data science or analytics is required, especially why today very less calls or more calls, or why only people are asking for a particular place, etc. So this why is giving rise to new trends in data science to be thought of, which is already done. That leads to explainable AI. Asking why is important, easy. It is always easy to ask questions, but answering depends on the context and the research. This is a small story, but I don't want to highlight every point of that story. Thing is that one of the Tesla models used by a traveler, the traveler had to meet a very worse situation. So immediately the research team, especially Tesla people, they wanted to explore it. What happened? Though there is an autopilot system in the car that will help the driver as well as the vehicle to go safely, but unsafe situation has come. So that means something else also, whether in terms of parameters or the conditions, have not been applied in the context. So that is the research out of this example. So not only according to Elon Musk, his team assumption finally was not only the autopilot system, but also the driver himself could not distinguish certain things. He's giving a kind of convincing statement. In that context, both humans as well as the autopilot systems, they will behave in the same way. But again, he is concluding, instead of depending on human beings, he wants to automate the things. So he wants to apply explainable AI or XAI. For your information, some of the language-related research is very less. NLP-related research is very less. Papers may be more. Language research is less, as well as more in image research. Image research is more, language research is less. Some of the conclusions derived, are they trustworthy? Are they correct? No. That's why people are moving from deep learning to a new level, where the reason or the purpose has to be explained. Some more layers have to be added. In fact, here I don't want to degrade deep learning. According to one discussion, though machine learning is improved, the applications done by machine learning has been improved by deep learning, within brackets, not in all situations. Deep learning seems to be better, but again, deep learning has got some drawbacks. We cannot train everything. Number of layers, very difficult to understand. Everything depends on the layer, number of layers. Expensive. We need powerful machines, GPU, and other things are. The hardware side is requirement is more to get some outcome. But even then, without explanation. That's why people have gone for XAI or explainable AI. Where to their shock, to their surprise,
Sir, I think your voice is not audible, sir. Participant will wait. Probably there may be some internet issues. We'll wait. We'll wait. He will join soon. The session is not over. Participants, please wait. The guest will join soon. The session is not yet over. There is some internet issues. Actually, the guest is actually joining again. Please bear with us. Thank you. Madam.
சொல்லுங்க சார்.
சார் திருப்பி ஜாயின் பண்ணிருக்காரு மேம்.
ஒரு
2 minutes பண்ணிடுவார் சார்.
ஓகே சார், ஓகே. I'll change him to co-host.
வந்திருக்காரா சார்? Welcome back, sir. Welcome back, sir. Your screen is visible, sir. Sir, you can unmute, sir.
Is it audible now?
Yeah, it's perfect, sir. It's perfect,
Yeah.
sir.
Yeah.
Thank you. Thank
Sorry
you,
for
sir.
the delay. There was a kind of disconnectivity.
No issue, sir.
I'm continuing.
Sure, sir.
So according to this, whatever have been done earlier,
Sir? Sir, again, your voice is not audible, sir.
Sir.
Ma'am, I'll inform you, ma'am.
Okay, sir. Okay.
Participants, please stay with us. There is some internet issue from the presenter side. Let us understand and we'll wait for the guest to join again. Thanks for your patience. Sudha ma'am, I spoke to him. Sudha ma'am.
சொல்லுங்க சார்.
I spoke to him. There is some internet issue from his side.
Okay, sir.
He will join again soon.
Okay, sir. We'll wait, sir.
Is it?
Yeah, fine, sir. Yeah, it's fine,
Yeah.
sir. Yeah, you can, sir.
So the next move is towards graph analytics, which is already there, but the new dimensions are coming up in the context of data science. As you know that the graph data is exploding, whether it is human related aspects externally or internally, by means whether any human movement or with respect to a single human or a person itself, the biological aspects, everything can be modeled as a graph. Here I would like to bring two things for researchers. If we are in a position to model anything as a graph with optimization technique, we are 90% completion of our research. Any problem is modeled in graph with optimization features, our work is over. So in that aspect, this graph analytics is playing a major role in data science also. As you know that when we want to get some result, even whether it is a single or a group of results in any search engine or anything, Indirectly, it uses a graph to finalize the outcome. Based on graph and subsequent algorithms, how analytics can be applied to link the properties, the features related to the edges, the nodes, is going to be graph analytics. Rather, we are going to navigate over the edges as well as the nodes to identify, to explore the complex relationships that exist between the entire structure. And this is applied in every domain: transport, banking, fraud detection, etc. etc. The major thing to be noted here is what are all taken as nodes. It can be a person or set of people, place or places, products, members, etc. And similarly, the lines connecting them can be friendships, network connections, hyperlinks, communication links, etc. So this graph analytics can detect financial crimes, fraudulent transactions. It is used in Uber, as you know, and also to identify the weaknesses in power grids, transportation networks. So its usage is plenty, not recently. It is for several decades. Especially graph cutting, partitioning, graph clustering, these things play a major role in bringing things to our requirements. Some of the important, often used algorithms, whether it is social network analysis or genome analysis or whatever it may be, healthcare analytics, you can see this cutting, searching, shortest path, longest path, page rank. I have given a question mark for longest path because I have plenty of examples on longest path itself. You see, if I am doing something, what is that? Not within time or in a longer duration, always issues will be there. But there are some circumstances, requirements where longer path also expected. So the earlier component was about how the graph analytics is playing a major role in what is it, data science and its applications.
Sir, 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 Sudha madam, Sudha madam, Sudha madam, Sudha ma'am, Sudha ma'am.
சொல்லுங்க சார்.
சாருக்கு திருப்பி நெட்வொர்க் இஷ்யூ போட்டு வந்துருவார், வெயிட் பண்ணுவோம்.
சார் நெட்வொர்க் இஷ்யூ இஸ் ஹேவிங்.
ஆமா ஆமா மேம், ஆமா மேம்.
ஓகே சார், ஓகே சார். பார்ட்டிசிபென்ட்ஸ் ஆர் வெயிட்டிங் சார்.
யா ஜஸ்ட் மேம்.
ஓகே சார்.
Am I audible now?
Yes, sir, it is
Yes, sir.
audible, sir.
Perfect, sir.
Yeah, there is a kind of
Yes, sir.
toggling between audio and video issue.
Yes, sir. Yes, sir. We are also facing the same here, sir. It's common, I think.
Maybe I'll have a quick recap where I stopped.
Yes,
I
sir.
won't take much time, because we are nearing to the end of this thing. I was in graph analytics, then I went to auto ML, where machine itself is going to take care of the machine learning activities to be deployed in the operations.
Sudha, ma'am?
Tell me, sir. Sir,
No, ma'am. Wait, sir. Wait for a second. Participants will wait. There is some internet issue going on.
Yeah.
Yes, sir. Welcome, sir.
So after this, I just gave a kind of overview of the various terminologies that I highlighted here in this discussion, like user generated, data generated, XAI, graph analytics. Then AutoML, and also the precautions to be taken care in all data science related applications is that how well we are good in domain knowledge, we are taking care of the updates in tools, what kind of population is taken for experiments, whether bias is taken care properly, how much we have understood the context, whether the experiments have been trained, tested, validated in complete sense. All these things are important to make the correct sense of data science. So with this, I conclude my talk. Any discussion can be. One thing is inferred from today's thing that especially my laptop, or I should have good data science assistants to predict when it will go online, audio issue it will have, or video issue it will have. See, every problematic situation leads to a good research domain.
Yeah, definitely, sir. That's fine. That's correct, sir. Participants, you can unmute yourself to raise your queries, or you can put your question in the chat box so that the guest will be able to answer the questions. So the permission is given for all the participants to unmute yourself. Either you can unmute or put your queries in the chat box. Sudha ma'am?
Yes, sir. Okay, sir.
Hello.
Yeah, there's a question.
Participants, you are given the option for unmuting yourself. If you have any queries, you can post it in the chat box or unmute and ask.
Hello.
Yes, sir, you can come out, sir.
I just want to know, you're talking about explainable AI. So I just want with an example, can you tell me what is explainable AI, sir?
Yeah, fine. See, actually, in normal situation, moving from machine learning to deep learning, we are able to, or we feel that we are getting better accurate results when compared to machine learning because of the layered concept. In deep learning, we are able to get better results. But whether the results got is apt, is it reasonable, whether something else also can be obtained through that results, getting outputs with the explanation, some more details. So that layer is called explainable AI or XAI.
Thank you, sir. Thank you.
So, good morning, sir.
Yeah, please.
So, this is Dr. Tamare.
Please.
So, I wish to know the difference between business intelligence and business analytics, sir.
Which one?
The basic difference between business intelligence and business analytics.
Yeah, as I already mentioned, a lot of new terms are coming. And some of the terms, they have become person oriented also. But based on the word intelligence and analytics, in the broader perspective, what we can think of is, see, we are in a particular situation. If at all we have earlier situation or its related data, based on that, are we able to get any inference out of that? From Monday to Saturday, something is happening. Today also that event will happen or not. Is it possible to predict it? Instead of predicting, coming to a conclusion based on the earlier ones. More bothered about the earlier events only, historical data. Whereas in case of data analytics, or more specifically business analytics, predictability is focused. In intelligence, predictability is not much focused. What happened is focused. What will happen will be there in predictive analytics or business analytics. Why this customer is not responding to this thing? See, in fact, I am getting diverted by this very important question. The same question was a major discussion on FedEx and UPS. I am really glad to have this question. UPS and FedEx, most of you must have heard about these two postal agencies. UPS is a government-based postal services. Rather, next came FedEx as a courier service. UPS applied business intelligence when it found that most of the customers are getting dropped. Why the customers are not coming? So business intelligence was applied there. If this happens continuously, what will be done? That was done by FedEx. See, FedEx, before it started its company, it has understood that UPS is coming down. Customers coming to UPS is slowly coming down. Now, what will happen to UPS? They found that many people who used United Postal Service or have moved from the region, or they are far away. Now FedEx analyzed that and started new locations, which UPS did not do. It did predictive. So intelligence is understanding the past, and analytics is knowing or assuming something from the future.
Thank you, sir. Sir, I also wish to know about graphic analytics, sir. And their application, in which field it takes more scope, sir?
Which one?
Graphic analytics. Graphic analytics. Because it was a new term I felt through all these sessions. I feel graphic analytics. I wish to know about it, sir.
Don't mistake. You are mentioning graph analytics?
Yes, sir. You were mentioning graph analytics.
Yes. See, as already mentioned, any system, if I am able to model it mathematically, I am considered to be a good researcher. Especially if we can model it as a graph, next level. If I can model it with graph and optimization, I am declared as a good researcher. So in that aspect, this graph analytics is a major thing that has been deployed in social network analysis, transport analytics, like Uber transactions, all those things, and even in food services also, like Swiggy or Zomato, these kind of things. So it is a kind of concept or technologies combined with concepts to know about the relations between the customers, the products, places, to improve the business, or to know what is that? Failure of the business. In fact, one of the recent articles on graph analytics for this thing, healthcare related thing is, after taking a medicine, whether it is an injection or a pills or a kind of tablets, how fast it is going to be cells. For a particular person, that cell is being modeled, and once the medicine is taken, how fast it is moving, how the blood circulation is helping him to make the medicine to move to the correct places. Are there any junks? Or which cells or nodes block them? That person might have taken medicines continuously, but no improvement. So graph analytics helps people to analyze the cell level, tissue level analysis on the movement of the medicine.
Thank you so much, sir.
Thank you, sir. Sudha ma'am? Sudha ma'am?
Yes, sir. Yes, sir.
I think we'll wind up the session, ma'am.
Yes, sir. Now I call upon Mr. Krishnamurthy, Assistant Professor, MCA, to propose the vote of thanks. Please, sir.
And thank you, ma'am. So, most respected Chief Guest of today's function, Dr. S.R. Balasundaram, sir. Respected colleagues, respected dignitaries, other head of the departments, professors from various institutions, other participants and students. It gives me immense pleasure to propose the vote of thanks for this valedictory function of this 1 week online international FDP. So, I have been conducting the international FDP for the past 5 years. We thank the management for providing us an opportunity for conducting event like this for promoting research facilities and research insights for all the participants. I express my sincere gratitude to all my senior administrators for their support and vision in conducting events like this. I thank our principal, Dean, for the constant source of inspiration for conducting this event. I thank our dynamic head of the department, Vice Principal Admin, Dr. J. Dileepan, for encouraging us to conduct event like this. I thank the event coordinators, Dr. Sudha Madam, Dr. K. Sudha Madam, and all our colleagues for making this event a grand success. I thank all the participants from various institutions, and I thank the Chief Guest of today's function, Dr. S.R. Balasundaram, sir, who is a visionary, is a domain expert in latest trends, also a senior professor in NIT. With his rich experience, he has highlighted a lot of insights in data science. Thank you so much, sir, for joining with us. Your speech was highlighted, and you kept the audience spellbound with your rich experience. And I thank you once again for sparing your time and joining with us for this event. Probably would like to invite you for a physical function in our institution next semester. Thank you so much, sir, for joining with us. And I thank all the participants for attending the event for the past 6 days. And I thank everyone for their support and the successful of this event. Thank you. Thank you, one and all. Thank you, sir. Thank you so much.
Sir, 1 second, just I would like to add a few lines.
Sure, sir.
Thanks for the opportunity given by the management, the department, Krishnamurthy and your other team members. And due to unavoidable circumstances, I had to go out, come back. And thanks for the patience, especially for the participants.
Yes, sir.
Patience is the only parameter which is required till the end of any system.
Yes, sir.
So thanks for that.
Yes, sir.
Thank you. All the best.
Sir, thank you, sir. Words are not enough for me to explain my gratitude on my personal behalf for accepting the invitation and presenting a wonderful session. Thank you so much, sir.
Thank you.
And kindly bless us so that in future we will be completing our milestones. All the research scholars and participants expect your blessings also. Thank you, sir. Thank you, person. Thank you, Sudha ma'am. Thank you, sir.
Thank you.
Thank you, sir.
Thank you.
Thank you, sir. Thank you,
Thank
sir.
you, sir. Good day, sir.
Thank you.
Dear participants, the feedback link has been posted in the chat box. Kindly fill in the feedback link. And thanks for your cooperation for the past 6 days. Thank you, participants.
Thank you, ma'am. Ma'am, when we will get certificates?
Ma'am, within 10 days, ma'am.
Okay, thank you.
Within 10
Thank
days, we will be sending you the certificates, ma'am.
Okay, thank you.
Okay, thank you, ma'am. Thanks a lot.
Ma'am, if you certificate send to mail or WhatsApp, ma'am. Hello.
Ma'am, sir, mail will be sending to your registered mail ID, sir.
Okay.
Certificates
Okay,
will
thank
be
you.
sent through the registered mail ID. Thank you, sir.
Okay. Thank you, ma'am. Thank you.
Hello, ma'am. Hello.
Tell me, ma'am.
Ma'am, I'm Dr. Usha from PG College of Arts and Science, Coimbatore.
Tell me, ma'am.
I didn't attend yesterday's event, ma'am, because of meeting other aspects. So what can I do, ma'am? Shall I receive certificate? I didn't fill the feedback form. Yesterday only.
Ma'am.
All other days I have attended.
Okay, ma'am. Surely we'll consider, ma'am.
Okay.
We are expecting around 75 to 80% attendance, ma'am.
Okay, ma'am. Okay. Okay.
We'll consider, ma'am. Surely, ma'am.
Okay. Thank you. Thank you for the nice sessions.
Thank you, ma'am. With all your cooperation and support, ma'am. Thank you, ma'am.
Thank you. Thank you.
Thank you, Sudha ma'am. K. Sudha ma'am. Sudha ma'am.
Thank you, sir. Thanks a lot, sir. சொல்லுங்க சார்.
ரெக்கார்டிங் இது ஸ்டாப் பண்ணிடலாம்.
Okay, sir. Sure, sir.